Welcome to the Software People Stories. I'm Shiv.
I'm Chitra,
And I'm Gayatri.
We bring you interesting, untold stories of people.
associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked.
and sometimes what didn't,
You will also hear very personal experiences.
and insights that would trigger your thoughts.
And inspire you to do even greater things.
Today, my guest is Robert Cooke, the founder of 3Forge, a provider of data virtualization and visualization technology solutions. In this conversation, Robert shares his origin story of how he got interested in computers even when he was a kid and how he liked to build things, whether it was in Lego or woodwork, and discovering that he could do a lot more building with software at much lesser cost, developing video games and accounting software, and also helping manage things in college with software solutions. When he took up a job in the Silicon Valley in the 2000s, he realized that data is very important. And the 4 V's, as he calls them, for data, which is about the volume, the velocity of change, the variety, as well as the validity of data. And that idea grew into this company, 3Forge, later, which he started in 2012. He talks about a lot of things, how at heart, he confesses that he is a coder. Whenever he gets a chance, he would do that even for 10, 12 hours a day. And he also talks some things about the software engineering compared to other disciplines of engineering, particularly electrical engineering, where he also has a certificate, about having something like the National Electric Code in the US for software so that it becomes easier for everyone to adopt and everyone to build based on certain standards. And the process of working on somebody else's code and how it's very hard to get rid of code that already exists, and how it could also be a therapeutic process. We talk about how he balances his engineering thinking and the artist thinking. Now, he calls developing software as an art, and how he balances maintainability as well. Listen on. Hi, Robert. Welcome to the Software People Stories.
Hi, Shiv. Good to be here.
Yeah, as we normally do, we'll start with your origin story and your career trajectory and to take the conversation from there. I actually am looking forward to this conversation, particularly after we had a brief chat the other day about your interest in coding and all the lessons that you've learned that would be useful for our listeners.
Sure, absolutely. Yeah. So I have been into computers all my life. Well, at least my memorable life. So even when I was a little kid, the first thing I'd ask for every year for Christmas was a computer. And, back in the early 80s, that was a tall order to ask for. I was also, and I think what really got me into computers, to step back a little bit, I was into Legos and I was into building things. I just love building anything. In fact, my hobbies are like woodworking, stuff like that. But I've always been into building stuff. But the problem is I realized if I wanted to build bigger and more interesting and more impactful things, it costs more money. So if I wanted more Lego sets, that cost more money. Mm-hmm. But I realized with computers, because I could get some time sharing at school, and I realized that you don't need more money to build more interesting software. And that's I think the great equalizer about computers is that it really is you against the machine. And so I got into computers at a very, very young age. I started off, I think, doing what a lot of kids do. I was into video games in the early 80s, so I was building video games. Then I started doing accounting software, and I started doing stuff to kind of help manage things in our college. And then just kind of wherever I was finding problems I was interested in, and I was coming up with software solutions for that, not really thinking about how to monetize software. That was a dream of mine, but it was just more about being able to build stuff. And my parents would always complain, that I would just come home every day and say, is there any software you guys need? Is there anything you can think of? Because coming up with problems, was like, if you want to build a new piece of software, but it's like, what can I do? And then, in 2000, so just step back.
Yeah, was this on the Ataris and the TRS-80s or?
No, I had a very
PC?
unusual computer called an Amstrad, but it was an IBM PC compatible.
Yeah.
It's a UK based manufacturer. I think they're out of business now. I think they've been out of business for like 15, 20 years, but or maybe they got bought by someone. But anyways, it was an IBM compatible 8086. I think my first one had just a few K of memory, so it was, it was a very small by today's. I mean, it was incidental by today's standards, but still, and in fact, I could probably spend a whole hour talking about how training on a computer with 128K of memory teaches you to respect, you know what I mean? Like not waste memory and not waste CPU cycles. But that's another thing. Yeah, so it was a classic PC. I've always been kind of a PC guy. I love Unix, but I've kind of stuck with the Intel series and AMD series. Xerox for time. Anyways, so we are, so let's see here. So now we're in 2000. I'm out in Silicon Valley working for some companies out there. And then I got a job at Bear Stearns in 2000. And I kind of going into it, I thought it'd be a pretty boring sort of job in finance where, you kind of like software developers go to die. Like you just go and you sit in a corner and you're writing code that moves a message from here to there and debits and credits, account balances, and it actually turned out to be an unbelievably fascinating set of challenges. And I've summarized it as the 4 V's, and I've said this for a long time, and now I found it's actually a thing on the internet. Someone searched it and it exists, but I don't know how, if it's coincidental, but I came up with this a long time ago. The 4 V's, which is you have very high volume of data, right? You have a very high velocity of data. Everything's moving quickly. You have a huge variety of data because you have all these different asset classes. And then the validity of data is absolutely critical. So I call it the 4 V's. And when you take those 4 together, you want huge amounts of data that can move very fast, but everything has to be perfectly accurate. And there's tons of different types of data. Well, that set me off on my career. And then in the rest of my, in the last 23 years or I would say because it took a few years to kind of get into it. I would say the last 15 years has been focused on how do I try to solve that problem in a generic way. So here we are at this podcast.
Yeah, wonderful. So the initial initiation that you had into software, you said, was about looking for problems to solve. Mm-hmm. So was there some method behind it, or how do you go about identifying a problem and then identifying a solution and then implementing it?
Sure. Well, that's a great topic. So, and this has been, I think, a lifelong journey that you just get better and better at as you write more software. And by the way, I should say I'm a self-proclaimed software addict. I write code 10 to 12 hours a day for as long as I can remember. I write it on planes. I write it on chains. If I have a laptop, I will write code anywhere I am. In fact, I was saying before, I promised myself I wouldn't write code on podcasts anymore because, I don't want to get distracted if there are interesting questions that I'm trying to code. But with that said, when you start off in the beginning and you have a problem to solve, or you come up with the problem, and I'm not going to talk about coming up with the problem because that really was just bugging people and kind of, you know what I mean? Just kind of, I don't know. That's a separate thing. That's kind of getting into just kind of socializing and stuff like that. But let's say we have a problem now that we want to solve. In the beginning, I would take a very brute force approach, which was I knew the problem and I knew what the solution was, and I would write the code in a very straightforward way. I'll give you an example. We had a club when I was like in my early teens, and in this club we had we kind of did things to raise money for the club, and so we had you could go and buy sodas and buy candy bars and buy different things, and when you bought that, we had a little laptop set up, and I wrote some software so that when you bought a candy bar, you'd hit candy bar, and when you bought a soda, you'd be soda, and this and that. The software itself, I literally had variables for storing the number of sodas and the number of candy bars and the number of various other treats that people would buy. And it was very hard coded. So if I wanted to introduce a new item, I had to go and change the software. Right. Now, as a little kid, to me, I didn't really think about that. It was okay, well, I've gotten something that works. But as you get older, you start to realize, well, you want to make this more generic. And so I think naturally, anyone who's been coding for even just a small period of time would realize, well, what you're going to do is you're going to make that more generic, where you have an item and then you have a list of the different items. So now you can add an item to that list, and you don't need to go changing your code. Instead, you have lookup tables and things like that. But then you solve it that way. Then you start to realize later on, it's like, well, maybe there's unforeseen types of transactions people are going to want to do, so you want to make that generic. So I think over time, you learn to look at the problem head on, but then you start to think, where is this going to evolve, and where can it be used in other ways, and how can I build the software more generic so it can have more applicability? At least that's what I love to do. I love to try to come up with, I would say, generic solutions, data agnostic solutions. And that's why I started 3Forge in 2012. So, I guess I haven't really introduced the company yet. We have offices in 3 countries, New York, we're also in London, and we have an office in Singapore. Many of the largest tier 1 banks rely on our software for those four V's that I talked about. But at the end of the day, the software that we deliver to our customers, it's the same software we give to all of our customers. It's a single branch of code. And I think very remarkably, it solved many, many different use cases. And that's really just an outcropping of what I was talking about at the beginning, which is I try to take all the different problems I've seen in finance and distill it down to fundamentals and core principles. And then from there, try to then build it back up into what does a generic solution look like that finance can use. And that to me is the holy grail. And the beauty is, I think that one of the coolest things about software is I've been writing software. I've definitely clocked at least 100,000 hours. There's no doubt about that. Probably more. And if you do the math, that's a lot of hours. But I still can go back and look at code I wrote a year ago and say, what was I doing? I could definitely make this better. And to me, maybe I was just such a bad coder in the beginning that it's taken this long to build it up. But I actually think but I like to be a little more positive and think that anyone, if you take the art form seriously, you just keep getting better and better and better at it until you retire. That's my belief. And I love that idea that it's something that you can keep improving. I think a lot of industries you start to taper off.
Yeah, I'll come back to a few key words that you probably mentioned. But before that, in terms of being a developer and your own transition and then how you kind of grew, we normally talk about one big S-curve or a transition from being an individual contributor to achieving things as a team, or what we call as programming in the small to programming in the large. How was that transition for you?
I think it's been somewhat organic, and I will say that what is so much fun about working in a team is if the team, I hate to be a little belittling here, but if the team is competent, right? So at 3Forge, I've been able to hire the team and very selectively make sure I'm hiring the people that I like to work with. But I think the great thing about working with the team of developers is you get this different sort of insight into how things are done. And I love working with smart people where they can sometimes help me solve a problem, or I can give them classes of problem, they can work on it. I also think once you start writing software that's intended for team members to be able to contribute to, you have to be a lot more organized and I would say rational in the way you put things together. Let's put it this way. If I was building software and I didn't think anyone would ever have to maintain it, you could probably take a lot of shortcuts in your naming conventions and things like that. And I'm not going to get into documentation. That's another topic. But, I think once you realize this has got to be something that can be maintained over time by a team of people, naming becomes very important. Making logical architecture decisions is important, and those sorts of things. I do think one of the things I've had to focus on, and I think I've done a very good job of it because I've seen the alternative, is that I have I have almost with an iron fist said, this is the structure and organization of how code will be written. I'm not going to say
Okay.
it's right,
Mhm.
and I'm not going to say it's wrong, but it's consistent. And I think that's something that a lot of teams don't do. And it's almost, it's the problem's almost getting exacerbated, which is this idea that anyone comes in and they contribute and they can do it in any way they want. I think people are creating a lot of technical debt. Again, I could talk a long time about what I believe and how detrimental technical debt is to large organizations. But I think that through a little bit of discipline, it goes a very, very long way. And I can make analogies all over the place. And, most industries have those disciplines baked in. By the way, I mentioned in the beginning, I love doing woodworking. I also took my homeowner's electrical exam so I can do, work around the house and stuff like that. And once you start to get into that, you realize that there's, at least in the United States, there's something called this NEC code, and it's very spelled out as to what you do. You know what I mean? The black is hot, the white is neutral, the green or the uninsulated is your ground. You don't switch the white and black. When you lay it out, you use these types of staples, and everything is done and organized and controlled because over the hundreds of years they've done this to stop literal fires from breaking out, right? I mean, you want to organize this stuff. It makes for a safer environment. It also makes for an environment where people become a lot more fungible. That just hasn't existed in software so much. I mean, there's nothing stopping you from deciding whether you're going to camel hump the case sensitivity on your variable names or this or that. But following those conventions makes it much easier. And I know this is it seems like a minute part of working in a team, but I think it's a really, really big part, because I've seen teams where you bring in new people that have their own ideas how to do things, ends up creating a lot of problems with best intentions.
Yeah. So have there been instances when, let's say, you look at somebody else's code to review and this urge to do a control A and delete?
Well, not just an urge. No, I will absolutely. Actually, what I've said, one of my favorite things to do is get rid of code. I mean, getting rid of code is like, it's really hard to do. It's very hard to get rid of code, but it's such a therapeutic sort of process because, in fact, I'll let me put it this way. One thing I've realized in much of life, and I can make this analogy all over the place, which is inserting or creating is actually the easiest. Updating or modifying is harder, and getting rid of or deleting is extremely difficult. So when I see code and I can do a control A and delete, I will. Now, I think your question is slightly different, which is, have I ever looked at code that was so bad I said you need to start over? Yes, absolutely. Yeah, all the time, which is fine, because look, you want to do things the best you can. And let me just prefix one more thing. It would depend on the case. Like if we're just trying to write a quick ends to a mean sort of script that's going to test something, I don't care too much if it's got a lot of extra for loops and things aren't done that efficiently, and we're throwing and building strings all over the place. Whatever. If it's something that's going to go into our core product, oh yeah, I'm gonna focus and delete it if I don't like it. Yeah.
So the related question is, in terms of probably the softer side, when you feel that urge, usually, and I've also been through this where if I've not written it saying I could have written it better, as a leader, we'll probably touch upon that a little more. I'm curious about your transition from a developer to a leader. But before that, when you have this urge to look at code and say that this needs to be replaced, and how do you respond? How do you react?
You mean, I guess you're talking about in order to make people not feel bad. I guess is really what we're talking about, to do it in a sensitive way, right?
And not that is one aspect. The other is also about an opportunity for them to learn from your experience. Right. Yeah.
That's exactly right. That's how I look at it. And I never just go and delete somebody's code because of, the reason I delete somebody's code is because it's either not performant or I don't think it is done correctly. or I don't think it is maintainable. It's going to be one of those. So I spell out the reason clearly. And then I try to give examples. I believe in something called managing through interfaces. Interface is a Java term,
Yeah.
right? Like, you're kind of giving the contract of the code, but not the implementation. And so, if I see someone struggling, I'll try to help them manage through interfaces, which is, look, no, because usually it's when I see, because again, I try to hire pretty qualified people. So when there is issues, it's usually because there isn't an understanding or a clear delineation of the inputs or outputs, or kind of like, where are we drawing the line in the sand in terms of isolation? And so I kind of will say, look, let's think about what the interface should look like. What are the inputs? What are the outputs? And then they can go implement it. But honestly, if they can't write a for loop, or they can't write the basic code that gets things done, then that's a different problem. But that's not usually the case,
Yeah. The other one was, did I hear you say that software development is an art?
Absolutely. I think it is
Okay.
totally an art. Yes.
Okay. So you also mentioned that you would like to tinker with things, and including your electrical certification and all that, which is more of an engineer's mindset, I would say.
Right.
How do you balance the two styles?
Oh, no, it's a great question. I think about that a lot. So first off, I am on all these electrician forums. I don't know why I belong to them. They just yell at each other all day about doing stuff wrong. But it is interesting because there's even a little bit of, I would say, a little bit of creativity when you're doing, and now I'm talking about like high power systems, not like residential. And I would also say, by the way, there isn't a whole lot of art to software if all you're doing is like a script to like load data in a batch or something. I'm not trying to trivialize here, but a lot of things, yeah, it's more just formulaic. Same thing with residential electric. It's fairly formulaic. You have your little, single double gang boxes. You've got your circuit breaker. You've got the wires. You've got the, but there's still plenty some creativity there. But when you get into more high powered things, that's where creativity comes in. And the same thing with building abstract software. Now, I would say with software, it really is an art form, because there's so many ways, just so many ways to solve the same problem. And to me, the big gotcha about software is it's this balance, and I can tell you where I lean, but there's this balance between maintainability of the software, meaning how easy for someone to come in and maintain it. How much time does it take you to write the software, and how well does the software perform? Meaning, the better it performs, inversely, the less resources it needs to get its job done. And now you struggle, like this perpetual struggle of when you're writing something, you've got to ask how core is it, and which of these three are you going to focus on? And that's where the art comes in, I think.
Yeah. So in terms of developing your team, what do you stress more on? Is it the RT side or the engineer side?
Okay, this is where I'm going to deviate from what I would necessarily recommend to other people, and other people are going to have to make their own decision. I consider myself pretty good at the art form now, just through all the struggles, trials, and tribulations, and making every mistake you can possibly make. I have a pretty good idea of how to architect systems. Generally speaking, what's right, what's wrong, what's secure, what's not secure, what performs well, and what doesn't. So what I look for, which helps balance out, or helps me, is I look for people with strong math backgrounds and strong logic backgrounds. I've hired people that don't know how to code if they really are good at math, and or they're really good at logic. Right? You know what I mean? And so those are things I look for. And again, I can't say that's what everyone should do, but as a manager, I have a pretty good idea of how I want to lay out the system. And I'm looking for people to help me do the work of getting these things done. And so that's an important thing. I will say another thing that I look for is problem solving. And interestingly, someone else told me this long time ago, and I've thought about it. The more I think about it, it's absolutely correct. I think the hardest part of software is actually debugging someone else's code. If I were to if I were to interview, I think actually asking, hey, here's a thing of code, here's a debugger, go figure out what's happening. You know what I mean? I think that's a very interesting, because it forces, I will say that's actually something GPT chat is getting very good at, very different topic. But it's something that as a human, we have to all of a sudden be able to place and understand and read through this, someone else's kind of foreign concepts, bring that in, and then be able to solve it. You know what I mean? So.
Yeah, this is probably also a nice segue into from being a developer. Now, what was the bug that bit you to start a company? The answer to that and a lot more in the next episode.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.